Morning all, welcome to session 2 of today, focusing on trees for high value wood products. I'm Marco Lorsberg and I manage the Specialty Wood Products program, which includes Douglas firs, cypresses and eucalypts for forest growers research. We cover the full value chain in this program with projects ranging from tree breeding right through to new products. And the program is supported by MBIE, Forest Growers Levies Trust, research providers and industry players. The priority for our specialty species really is quality. We have no intention of competing with radiata, but we will aim to address high value products that do not suit radiata. Today we'll hear from 3 speakers covering projects under this program, as well as detail about the future of funding in specialty species. Last but not least, we'll also hear about progress on work with TOTRA. We are very lucky that we've got some passionate speakers in this field, and it's fantastic to have this energy being applied to specialty species. Firstly, we're going to hear from Paul Millen from the Marlborough Research Centre. He's the project manager for New Zealand Dryland Forests Initiative, and he is the freshly minted New Zealand Forester of the Year. His work with durable eucalypts goes back to at least 2003, and he seems to have almost endless enthusiasm, which is great. He's going to talk about regional strategies for a range of specialty wood species, and Paul is involved with several other projects around naturally durable eucalypts, and he also grows and processes his own trees. Next, we're going to hear from Tony Withers from Science. She's a senior entomologist, and she's going to talk briefly about pests and disease in specialty wood species. She doesn't have time today to be covering Paropsis, but it's worth noting that the SWP program has been supporting Scion regarding Paropsis control, and we are lucky to have a very small and clean colony of Edia dineris, which is a natural parasitoid of Paropsis, and that has been approved for release. If the insect gods smile on us this summer, and if anyone has a direct line to the insects god, it's definitely Tony, then mass rearing and getting the parasitoids out into the forests of Oji in the central North Island and southward exports in Southland will be able to start. This is a slow and steady process, but if successful, it will deliver a natural, chemical-free approach to controlling Paropsis and potentially EVB as well. Following Tony, we're going to hear from Minghao Li. He's from the University of Canterbury, Associate Professor there with the Department of Civil and Natural Resources Engineering. He's going to cover Douglas fir being used as in CLT, cross-laminated timber. I think this is a brilliant use for Douglas fir, and the work that is required to provide a valuable technical information for engineers and architects to be able to both design and specify mass timber structure utilising Douglas fir CLT. Following Minghao, we're going to hear from Bart about the future investment in contingency and alternative species. Bart works for the Forest Growers Research, and he's the research director for the Forest Owners Association. The funding in this area is particularly relevant right now as the funding for our program, the Specialty Wood Products program, ends next year, so it's key to find out and keep some momentum in this area. Last, we're going to hear from Ramona Radford from Science. She's a portfolio lead for the Distinct Value Indigenous Wood Products, and that's underneath the Forest to Timber Products impact area within the new Science structure. She's going to talk about the TOTRA Industry Pilot Initiative, and part of that is seeing TOTRA valued again. There are a large number of people involved in these projects that you will hear about today, and I would like to take the opportunity to recognise that the progress being made and the success we've had has been due to team efforts and collaborative work from both research providers and industry partners. There will be an opportunity for questions after Ramona's presentation, and I look forward to some further discussion on these projects. Thank you.
Good morning. Paul Millen's my name. I'm the New Zealand Dryland Forest Initiative Project Manager, and I'm a member of the Specialty Wood Products Technical Steering Team. This morning I'm going to share with you work we're doing on regional strategies for specialty wood product species. It's useful to have a historic perspective, as it's 40 years ago that the New Zealand Forest Service released its exotic special purpose species policy. This was a strategy for local supply of special purpose timbers to meet domestic needs for end users for which radiata pine may not be suitable. Native timber supply was declining and the availability of imported timbers was also expected to reduce. There's a range of uses identified. The particular importance were wood properties where higher standards in decorative features, dimensional stability and surface hardness were required. The New Zealand Farm Forestry Association took up the policy as Neil Barr, the president, was a pioneer of alternative species, and the policy was also supported by the Forest Research Institute scientists known as the Special Purpose Species Group. The legacy of that policy are the thousands of mature small stands of alternative species planted throughout the 1980s and 90s by both farm forest growers, corporate forest growers and farm foresters. The National Exotic Forest Description in 2019 estimated there's actually 67,000 hectares of alternative species across New Zealand. The key species included in the policy were the cypresses, macrocarpa and lusitanica. There's a number of eucalypts, redmans, fastigata, delicatensis, Saligna and botryoides, as well as Australian blackwood and black walnut, which were of keen interest to the late Ian Nicholas. Nightens was added to the policy at a later date. If you consider the market opportunity that was identified by the 1981 policy, if you look at that today, it's definitely developed. I'm not going to take you through this table, but there are some key areas, key product areas that we've done some assessments of the market opportunity. Of particular interest is the domestic substitution of CCA treated sawn timber using naturally durable products in its place. This is of significant scale for both sawn timber and posts and poles. There still is the need to substitute the high value hardwood and softwood imports, which haven't declined and nor has their availability. And you can see they've been substantial. We also think there's a great export market opportunity for New Zealand to produce specialty wood products that can be sustainably certified in the market. And we also want to see the use of these species in engineered wood products, particularly high stiffness hardwood veneer that could allow for building taller and stronger buildings. So since 2015, the SWP R&D program is focused on developing New Zealand's opportunity to produce exotic specialty wood products from the maturing resource. The work has included a pilot project to have a look at actually how much wood could there be in New Zealand, and so a methodology to do a New Zealand-wide survey and inventory is under development. As a first step in the pilot program, 2 tasks were undertaken. The Marlborough Research Centre obtained data and maps for alternative species resource from corporate forest owners in Hawke's Bay with a total of 914 hectares mapped. And the School of Forestry identified and quantified the area of alternative species held by small-scale owners using multispectral Sentinel imagery and Google Earth imagery. When you combine the mapping and show it across the region, this is what you see. There's a total of 4,480 hectares, but it's scattered across the entire region. It would be difficult for any harvesting contractor and wood processor to decide where would they focus so as to find a resource in order to get logs to process to get wood products to market. A key conclusion for us from this is it's best to cluster future planting to achieve scale, and this has become a key focus of our strategic work. Let's also look at the specialty wood product supply chain. I'm going to quickly run you through it. You'll see that there's a lot of steps involved in getting a wood product supply chain going. I'm not going to take you through them. I'm just going to click on, and you'll see that as we get from seedlings to forest to harvesting and transport to processing, in order to get the products that we've identified to the markets, that it's a long supply chain, and it takes a lot of people and a long time for that supply chain to develop. So that's another significant challenge. However, despite this, we think New Zealand has opportunities to plant more forest, to produce specialty wood products. They do all have the same challenge of developing a sustainable supply chain, and they need to attract investment in new planting and R&D, and a strategy and leadership is going to be needed for building industry capability in markets. We've been working on these strategies and have completed one for the NZDFI. It's a multi-regional durable eucalypt hardwood strategy. We've done some work looking at the Douglas fir resource, and there's potential for greater utilisation in New Zealand of this resource. We're under development with a cypress strategy that involves the Farm Forestry Association, Cypress Development Group, and others in industry who are interested in this species. And we've started work on a small-scale sawmilling industry strategy with a survey completed, and we have a next stage plan to engage further with the industry. A quick look at the NZDFI strategy. The map here shows the overview of our goal for 12 wood supply catchments to be planted by 2050 throughout New Zealand. The catchments are focused on a future industrial site for sawmilling or hardwood processing of around 5 hectares. And we've used an indicative catchment boundary of 40 kilometres radius around that site to demonstrate the catchment concept. All of the locations have good rail, road and port connections for log supply and to transport hardwood products. So this is the focus that we think is needed. If you look at the type of sawmill that could operate if these wood supply catchments can be planted, this is an Australian example I visited in 2009, owned by Boral, sawing up, in this case, old growth and regrowth eucalypt, ironbark, stringy barks and spotted gum into a range of wood products that are shown in the photos here. This type of mill could employ up to 50 people, and alongside a processing site could generate significant GDP into a local region. Here's a more detailed land use analysis that we undertook around Wairoa as one of the focus areas. This work was based on work we did with Sion, Peter Hall, looked at technical analysis of the size of mill that could be suitable, and we've done the analysis of the area of land. And if you just look at the land use classification, 6 and 7 land and existing plantation land, there's 235,000 hectares, and with only 5,000 hectares being planted at 170 hectares a year, the area of proposed forest to support the mill is only 2.1% within that 40-kilometre wood supply catchment. If this was achieved, the direct employment created could be substantial, particularly once the sawmilling's underway and if remanufacturing can be included on the site. And we can see that the annual estimate from work by Peter Hall suggests a contribution to regional GDP of 82.5 million, with a return on capital employed of 25%. The national opportunity this presents is a target of 60,000 hectares being planted by 2050, so that all 12 wood supply catchments can have a future hardwood processing business with a 360,000 cubic metres of hardwood lumber and a contribution to GDP of around $1 billion. There's a lot of future employment possible as well. We, the NZDFI, want to make this happen, and we've had a 1 billion trees partnership grant to accelerate the production of our improved planting stock, with our two priority species being Eucalyptus persistioana and global deer. First generation of over 250,000 genetically improved nursery stock will be planted this year, and the seed production clonal work has been led by ProSeed at their North Canterbury site, an NZDFI partner. A few comments on other species, specialty species outside of the SWP. There's redwoods, and planting started, and significant planting started in New Zealand in 2001, led by the US-owned New Zealand Redwood Company. There's been forest first planted in North Canterbury and the Rangitikei district, but the focus in the last 10 years has been on new forests in the Taumarunui district, with the company strategy to have enough forest to supply a future sawmill. I think there's something like 20,000 hectares of redwoods now planted in New Zealand. Tasmanian blackwood, or could we call it all blackwood? There is a small resource that was planted by some keen farm foresters that's been well managed. The largest resource on the South Island's west coast is owned by Ngāi Tahu, although that may have changed recently, I understand. There's also poplar being talked about and what could be done with the widespread farm woodland resource that's throughout much of the hill country of many regions of New Zealand. And not to forget the native forests that still produce specialty wood products. Harvesting still continues from these, small-scale harvesting, with 140 plus sawmillers licensed to do this. The Northland Tofara Working Group have a strategy that they're hoping to extend to other regions based on the regenerating resource. And more recently, Te Uraraka, New Zealand Forest Service, have announced they're developing a national strategy on new native forest plantations. The key thing, I think, with new native forest plantations is regional seed collection and propagation programs are needed. Anyway, I'm going to finish there. There's an excellent team of dedicated people that support the NZDFI that I want to acknowledge and thank for their input. So hopefully that's been of interest to you, and I look forward to taking any questions.
Kia ora, ko Tony Withers aho. I'm an entomologist in the Ecology and Environment group here in Sion in Rotorua. I'm presenting a talk today on not just pests, but also on the diseases of specialty wood species. And I'm speaking today on behalf of my co-authors shown here, Michael Bartlett, Roanne Sutherland, and Daryl Heron. I'll be updating you on new knowledge from research undertaken at Sion on pests and diseases which impact upon tree species of interest to the Specialty Wood Products Partnership. Firstly, I'm going to introduce you to the potential threat posed by a new invasive beetle to hardwoods, especially eucalyptus. Secondly, I will talk about the threat of myrtle rust to Eucalyptus globoidea. And thirdly, the potential threat of cypress canker disease-causing pathogens Ceridium to cypresses. Firstly, the granulate ambrosia beetle, fondly known to entomologists as gab. This beetle is a scolited wood-boring beetle, Xylosandrus crassiusculus. It's a successful global invader that targets living trees and is capable of killing even entire large specimens or causing the whole branches to die back. It was first found in New Zealand infesting oak trees in an Auckland park in the summer of 2019. Its current known distribution is in West Auckland, centred on Kumeu, but no formal surveillance is occurring, so this is not likely to be an accurate map. Scion obtained permission from landholders and MPI to undertake some trials of different trapping methods between 2019 and 2021. This enables us to establish the timing and the number of generations the pest is undertaking in Auckland. One of the methods that we've illustrated here on the left was to hang freshly cut bolts of wood soaked prior in ethanol. And this is a simple way that we can look at a range of different tree species that might be attacked by GAB. You can see in the graph, in the blue, Eucalyptus vastigata was attacked at a similar rate to avocado in orange, which is a known host tree of this pest overseas. But they were both attacked slightly less than Taiwan cherry, which is a known preferred host species, presented in the graph in green. This confirms eucalyptus are hosts and are vulnerable to this pest. So how much of a concern is GAB for forest growers? Well, GAB attacks any trees from very young to mature trees, but particularly those under physiological stress. Luckily, it's not a known pest of Pinus radiata or Douglas fir. It prefers hardwoods, especially thin-barked deciduous species, including eucalyptus, but also acacia, avocados, apples, pears, and species such as oak. It has a wide host range. We can confirm GAB also infests swamp pine, Pinus aliotii, the freshly cut logs, and F2 hybrids with the tropical species Pinus caribea that were growing in Queensland. This does make us a bit nervous. We've shown that the beetles are undergoing 2 generations per annum in Auckland, and we know that trees under physiological stress, such as having disturbed roots, having recovered from drought or waterlogging, those trees give off ethanol and are then targeted by the adult female beetle who bores in, creates a gallery in which she lays her brood. We do not know how effective GAB will be at vectoring pathogens when it emerges and moves from tree to tree. But few management options exist for this pest. So Scion's recommendations are that nurseries and nursery growers should be made aware that waterlogging needs to be avoided at all costs, and surveillance for these distinctive, though rather delicate and short-lived, what we call noodles in this picture. These are little extruded bits of sawdust, and they are a diagnostic symptom of GAB and should be reported via Finder Pest. But note, they're so delicate that after heavy rain, they are washed off quite quickly. My next example covers myrtle rust and evidence for the risk that myrtle rust poses to eucalyptus. As you probably know by now, a strain of Ostropyxinia is the agent responsible for myrtle rust. When myrtle rust arrived in Australia, preliminary screening of 32 species of eucalyptus plus 9 hybrid cultivars was undertaken in the laboratory using very young plants. Seedlings were given a huge inoculum, and shown in this picture here, you can see the cloud of spores. This is a higher loading than they're likely to experience in nature, but it gave the experiment confidence in the results that all trees had been exposed. So the results shown here were variable between species of eucalyptus. They range from very susceptible in species such as Eucalyptus globoidea and teraticornis. Most species were considered to be variable. That was the majority of the rest. And there was even a few that showed full resistance, such as Eucalyptus cladocalyx. Highly susceptible native trees in Australia are being driven to local extinction, especially in areas where myrtle rust is prevalent, as the seedling recruitment fails and the trees die back from the tips. So myrtle rust, what kind of threat is it to New Zealand? Since its arrival in 2017, we have the same pandemic biotype as is present in Australia. In Australia, the known host range has doubled from 32 to 69 genera of Myrtaceae, while the most serious disease expression in New Zealand natives has so far been on Lopha myrtus. In Brazil, the impact of myrtle rust on the eucalyptus forest industry is severe. Resistant clones and species are continuously developed and redeployed in an attempt to outcompete the rust as it mutates to overcome the resistance. To date in New Zealand, there's been only one record here in the field on eucalyptus, and it's no coincidence it was on Eucalyptus globoidea. This is the same species predicted in the previous slide by the Australian laboratory trials to be highly susceptible. So what kind of risk does it pose to our eucalyptus industry? Eucalyptus globoidea is a magnificent tree. It's one of the primary species in the New Zealand Dryland Forest Initiative Tree Improvement Program. It's a durable hardwood, a white stringy bark, a monocalypt. It's a particularly exciting tree, being resistant to most insect pests in New Zealand, especially Paropsis. And it produces Class 2 durable timber with good in-ground and above-ground durability. It suits warm to cool sites and a range of soils and produces excellent growth rates with a really high mean annual increment of over 30 cubic metres per year. And it can grow 2 metres in height per annum. If you look in this picture, you'll see a little person, the measurer of this tree, being dwarfed by the just 12-year-old trees. The 2012 report from Ian Nicholas and Paul Millen highly recommended Eucalyptus globoidea as a tree for growing in the Bay of Plenty. Myrtle rust life cycle research trials were undertaken at Scion earlier this year within our pathogen containment facility room, which is a type of fog chamber. 192 seedlings of Eucalyptus globoidea were inoculated, along with control Syzygium jambos trees. Despite a very low spore germination in this particular trial, which was about 1/10 of what we were aiming for, 1/4 of all the globoidea seedlings developed symptoms. This level of inoculum is probably closer to what would be experienced in the field. So we can now confirm this is the actual damage that was produced, and the seedlings of globoidea are the most susceptible life stage. They're definitely susceptible to myrtle rust under the low inoculum loading and the high humidity that they were presented with in the laboratory. At this level, impacts in the field could be severe. The actual risk presented to globoidea plantations in the field will depend on climate and siting. You can see here in these myrtle rust maps produced by Rob Beresford from his modelling work that the drier areas that are shown in green have a significantly lower average infection risk compared to the higher risk areas that are in pink, and the maximum risk under ideal weather conditions are shown on the right in red. With these risks, you can see that Northland and the Bay of Plenty are no longer considered to be suitable for siting globoidea if it's going to be this susceptible to myrtle rust. And even some risk will remain in the Gisborne, Hawke's Bay regions when the weather is suitable for myrtle rust. So Eucalyptus globoidea perhaps needs to be a dryland species from now on to avoid the risk from myrtle rust. And families could be screened for their resistance in the future drylands breeding program if required, but siting recommendations seem the most obvious. My third topic for today is cypress canker disease in New Zealand. We have a number of cypresses in New Zealand, and they form an important specialty species for the SWIP program. Canker disease is a serious dieback issue, especially for Macrocarpa and Lusitanica. It kills the trees. This disease severely limits the expansion of New Zealand's about 10,000 hectares of planted cypresses. We've been relying heavily upon breeding for resistance up till now, but still need to remain vigilant with our biosecurity awareness for any new pathogens arriving, due to having 2 native cypress species in our flora. We had previously understood that Ceridium cardinale was the primary agent for cypress canker disease, but became aware of Ceridium unicorni in the North Island also. It was uncertain which was the most pathogenic, and recent findings from a paper published in 2018 revealed numerous new species existed around the world. Our colleague Te Whauranga undertook this laboratory research and cultured and extracted DNA from 63 isolates within Scion's fungal culture collection. She analysed the BTU-B region of the genome. Before 2019, we thought we had just 3 species of Ceridium, cardinale, caprese and unicorni. But now the recent research has revealed, and here's a little portion of the tree shown on the left, we've got at least 3 additional new species. Earlier work focused on resistance to a generalised cypress canker. To correctly identify the isolates identified as Ceridium, additional data is now going to be needed from additional gene regions. We need to do more work to understand the distributions and the host associations of these 3 new species, especially in light of climate change and new pathogen interactions. Industry wants to de-risk these options inherent in promoting the current resistant cultivars. So, just to recap, my conclusions from today's talk have been: granulate ambrosia beetle is here in New Zealand. It can infest eucalyptus. It's currently in Auckland, and we need to increase the awareness within tree nurseries that the importance of avoiding waterlogging and other tree stress, and to increase the surveillance for the presence of this pest. Eucalyptus globoidea is the most promising monocalypt under the Tree Improvement Program at the Drylands Forest Initiative. Seedlings are now known to be highly susceptible to myrtle rust, and we should alter siting recommendations to only drier areas of New Zealand to offset this risk. And thirdly, we've now revealed we have at least 6 Ceridium cypress canker disease isolates, not just 3 in New Zealand. Research on pathogenicity of these to the promising cypress species and hybrids developed can be undertaken in parallel to the breeding. I've got a lot of colleagues and funding that should be acknowledged for all the aspects of this research. Thank you very much for your time today, and I'll look forward to answering some questions later.
Good morning, everyone. Thank you for coming to my presentation. Today, I will talk about Douglas fir CLT, which is obviously an innovative engineered timber product for New Zealand. So in the last 4 years at the University of Canterbury, we've done significant amount of research to understand basic properties of Douglas fir CLT, as well as developing engineered solutions to have more efficient use of Douglas fir CLT in the building system. So this presentation was also prepared by my colleague, Dr. Thomas Lim, who recently joined School of Forestry from the US. He has a very strong background in wood product development, manufacturing and processing, as well as timber engineering. So my presentation will have simply 3 parts. First, I will give you a brief introduction of CLT, including some numbers and facts of global CLT production, and a brief introduction of CLT manufacturing process and CLT product standard in North America, and 2 recent CLT buildings using mainly CLT for structural application. And then I will talk about the Douglas fir CLT research, a number of projects at University of Canterbury, and then wrap up my talk with some conclusions. You probably are quite familiar with this different engineered timber product, so they can be used to build multi-story mass timber buildings. So glulam, LVL, they are very strong and stiff, and they can be used for panel type of application, as well as beams and columns. And CLT is relatively new. It was developed by Europeans in early 1990s. In the last 3 decades, however, CLT has gained significant popularity in the global construction market. According to Forest Product Annual Market Review from the United Nations, note that this review was published almost 2 years ago, before the pandemic. At that time, the report shows in 2019, the global production of mass timber panels, primarily CLT, was estimated as 1.4 million cubic meter. By 2025, it was forecast to more than double. In 2020, annual global CLT production is predicted to exceed 2 million cubic meter. But again, we don't have the exact number now because of the pandemic. In 2020, the global CLT production capacity is estimated at 2.8 million cubic meters, but that also includes CLT panels used for industrial application. For example, CLT panels can be used for industrial matting for for example, oil or mining business. I know that if you look at CLT application for buildings, Europeans and North America produce almost 90% of the CLT. In Australia and New Zealand, we produce 7% of CLT for building applications. This table shows a list of major CLT producers in Australasia, in Europe, and in North America. I know that in North America, most of these companies started to make CLT product not a long time ago. And that's mainly because in the last decade, there was a huge demand for CLT product for building applications. And then these companies started to invest in CLT manufacturing. CLT can be treated as a type of jumbo plywood. Instead of using thin veneers, CLT consists of sawn timber pieces. So this short animation shows how CLT is made. Starting from sawn timber as laminations, applying adhesive, and press different layers of laminations, then form the solid panels, then deliver to construction site to form the structural skeleton. So it is a very efficient engineered timber product, and particularly they can be prefabricated and they can be assembled on construction site in a very efficient way. So this flow chart shows the CLT manufacturing process. We start from timber drying and do proper grading for laminations, do trimming, finger jointing to form longer pieces, and do proper planing. Some companies may do edge gluing, but some don't. Then surface gluing we must do, and then lay up different laminations or different plies through cold pressing process, either by mechanical press or vacuum press. We can make large size CLT panels and then do the final finishing, then deliver to construction site. In North America, manufacturers follow this standard, APRG 320, to manufacture performance rated CLT product. This standard has been proved by the US and Canada and was developed by APA, the Engineered Wood Association, based in Tacoma in Washington State. So the basic lamination property essentially is for dry surface use only. Make sure the moisture content in lamination is low. This is similar to structured timber application for buildings. We need to keep timber dry. And the purpose of this product standard is to ensure consistent product quality and reliability. And the standard also specify dimensions and tolerances, performance criteria, test method, and quality assurance process. And also for structural engineers, the product standards specify design properties for selected grades. And the standards include most of commonly used softwood species in North American construction market. So this long list shows different grades of CLT with different layups or recipe. Pretty much following these recipes, the manufacturers will be able to provide CLT product with the specified grades. So for different species, for example, if we want to make CLT product that will be accepted by North American market, but we're using New Zealand grown Douglas fir or radiated pine, so we can follow this alternative path to make CLT product that will be approved by North American market. So the standard also provide two sections here, 8.4, 8.5, to show how the other species or imported species can be used for CLT production in North America. From the structural point of view, CLT is a timber version of concrete slabs. So these CLT panels are prefabricated and they can be delivered to construction sites and using mechanical fasteners, steel brackets. Construction team can quickly assemble these panels to form walls and floors and roof structures and quickly build a CLT building in a much more efficient way compared with light timber frame construction technology. So I want to show you two buildings recently finished, one in Christchurch, one in Auckland. So the Christchurch building used CLT as the floor panels, and the Auckland building here used CLT for most of the structural components, including walls and floors and roof structures. So this is a really good example to showcase how CLT can be efficiently used for this multi-story, large-scale mass timber construction. Next, I will talk about a number of Douglas fir CLT research projects at the University of Canterbury with the purpose to assess New Zealand grown, New Zealand made Douglas fir CLT product using New Zealand grown Douglas fir species. So we sourced Douglas fir timber from South Island, and these timber all had the SG8 grade, and we also asked XLAM at that time in Nelson to manufacture 3-ply, 5-ply, and 7-ply CLT panels for us. And these panels have various lamination thickness, and we've done extensive research to evaluate CLT, Douglas fir CLT basic material properties, working on innovative connection solutions to connect Douglas fir CLT product. And also we developed innovative shear wall structures, mainly for Douglas fir CLT buildings to resist high seismic load. So this slide shows the screw withdrawal test, and you notice that we are using high capacity self-tapping screws. They are made out of hardened steel with very high yield strength, 3 times stronger than normal structural steel. And this particular testing is to understand withdrawal properties, because these long screws often are used in CLT construction to rely on its withdrawal capacity to transfer load. We also developed new type of hold-on solutions for CLT wall structures to resist earthquake load. In this project, we install screws with different installation angles, and we also tried different repair strategy to explore the possibility of retrofitting CLT, Douglas fir CLT structures after major earthquakes. We also tried these large steel dowel connections in CLT, again used as a hold-on connections to resist earthquake load in CLT shear wall structures. And you notice that these type of connections are able to resist high load, and also it can dissipate a lot of energy because these steel dowels have bent and timber has been crushed significantly, which means a lot of energy dissipation occurred in these connections. We also worked on this wood carpentry joint to understand how these joints can effectively transfer shear load between CLT panels. And in practical project in Christchurch, engineers have specified these type of connections in CLT buildings. We also worked on large-scale wall structure testing with the purpose to develop low-damage Douglas fir CLT wall systems for seismic design for New Zealand CLT buildings. This is a currently ongoing research project, again on Douglas fir CLT wall solution. We now introduce steel link beams into coupled Douglas fir CLT wall systems, rely on steel link beams to dissipate more earthquake energy, and we can protect Douglas fir panels in major earthquake event. So we know for timber, it's very difficult to repair if they've been damaged significantly after major earthquakes. So we believe Douglas fir CLT is a high performance, high value added mass timber product. So it is ready to be implemented in buildings in New Zealand. And overall, we believe Douglas fir CLT performed as good as other CLT products in Europe and North America. And also we need to work on developing high capacity connection systems to make more efficient use of Douglas fir CLT in building applications to resist high earthquake load. This is the list of publications coming out of recent Douglas fir CLT research. And again, I want to thank this research team, my collaborator and my student who spent a lot of effort and time to study Douglas fir CLT, to explore new applications of Douglas fir CLT in building design. That's all. Thank you for your attention.
Good morning, everyone. I'm Bart Challis from Forest Growers Research, and today I've got the opportunity to talk with you about some of the activity that we've been working on around specialty species and contingency species. So I guess I'd like to start by recognising that the topics of specialty species and contingency species are large and complicated. There's lots of existing knowledge and there's been lots of historical activity. The purpose for FGR is not to derive solutions, but to support progress to the science and innovation strategy. In doing that, what we've attempted is to revisit the choices and the challenges that we face, tap into the knowledge and the experience that already exists to identify areas where research may be needed, and to identify and create opportunities for potential co-investment. Firstly, I guess it's worth reminding people that the Science and Innovation Strategy is a key document that's used by both the FRC and subsequently FGR to identify areas for priority investment where research can make a difference. In the strategy, there's a specific acknowledgement that species diversification, as well as ensuring contingency species options for radiata pine, are both high priority areas. So what's been happening? In terms of specialty species, over the last 6 years, the major levy investment in developing specialty species has come via the SWP program. This program is a consortium of partners, including FGR and industry, as well as farm forestry, and is matched 50% with co-funding from MB. Collectively, the investment between the partnership and Scion through its SSIF fund represent around $1.4 million per annum. This activity is really focused on creating high-value wood products and regional strategies for durable and non-durable eucalypts, Douglas fir, and cypresses. And whilst the program's not holistic in the sense that there are a variety of number of other species that could be included, it's been a highly successful program. The program's ending in 2022, and given changes in funding frameworks, there's no ongoing option for funding via MB. So the question that the partnership program and FGR are now faced with is where to from here. We started that process with a workshop held in Wellington. We got a diverse group of forest owners, processors, government, and others together to identify the forces that are both enabling or potentially blocking a future of high-value specialty species. We also talked about how we could imagine a future where specialty species are a natural part of the sector, and focused on identifying key attributes of the various species and where effort could be focused and why. I won't go into the detail of the different workshop activities. However, a key output from that workshop was the strategy diagram presented here. In that diagram, what we look at are some of the things that could be working in our favour and things that are potentially working against us. We looked at it both in the general sense of the forest futures, as well as the growing or the processing sides. And in that, we identified the attributes that we felt were reasonably important for a successful outcome. So as you can see, the ability to predict growth and growth sites and climate conditions was considered to be a high priority for all species in the growing space. Whereas tailored genetics to match sites, for example, could be considered a more specific attribute that may or may not be necessary across different species. We also looked at the potential for species to be re-engineered and identified the importance of naturally durable species to create higher value products. In the bottom part of the diagram, we looked at some of the conversations and frameworks that we could undertake to both optimize today's state as well as transforming the sector for tomorrow. This exercise proved useful in the sense that it was a holistic approach independently undertaken from SWP, and therefore allowed a overarching framework to be produced that we could then use to take forward. So in doing so, really the key focus is not to lose momentum. The SWP program has been successful and has come into an end. So we need to make sure that we work towards developing continuity as much as possible. In doing so, FGR is aiming to support and help where appropriate to coordinate the securing of funding for ongoing investment. To do that, what we have undertaken is a continuation of the species review process that was initiated in 2020, and that report's available on the FGR website. We've also used the workshop outputs and the key priority attributes to develop an assessment framework. This is where we are today. The next step is really to circulate and undertake an initial screen using that framework across a large array of species. In doing so, what we're hoping to do is identify a subset of highly ranked species that we can then do a deeper dive and generate a list outlining the specific knowledge gaps by species. And lastly, once we have those attributes identified, we're looking to identify funding partners and develop proposals to take the research forward. And the objective is really to do that, as I said, prior to the end of SWP, which will be at the end of 2022. In terms of the contingency species, I guess the core issue that we're facing is that there is no readily deployable alternative to radiata pine. And there's a fundamental question around whether there needs to be. We see this activity as distinct to specialty species, although potentially related. And that's primarily because the focus of developing a contingency to radiata is one that needs to operate at scale and take into consideration existing supply chains and value chains in a way that establishing new higher value specialty outcomes may not need to do. Similarly to the specialty species, we undertook a workshop in Wellington where we explored the forces shaping our industry's future. We reviewed the potential to control or influence the extent at which a force will shape our sector and discussed the potential to respond through action. This slide identifies some of the higher level unstoppable trends that the group identified influencing today's forestry sector and potentially areas that will be important into the future. So what you can see is some nationalism, some emerging carbon elements, some vulnerability around biosecurity and loss of resilience, the impact of climate change, ownership dynamics, societal expectations and perceptions, the pace of change and disruption occurring globally, the operating practices and health and safety around our people, and the intensification of the primary sector and the associated biosecurity risks that poses. In each of these, we identified pole positions that the sector could find itself in. So, for example, from a societal perspective, we could find ourselves in a position of being a national disgrace, where we have low public support, a desire to see fundamental change in practice, and potentially an appetite for the industry to diminish. The other end of the spectrum is that we're highly connected to society, where the New Zealand public embrace the contributions that our sector make, both economically, societally, and socially. And similarly for things like climate change, where we're wrestling with predictable climate change that potentially we could foresee into the future versus unpredictable climate change. And in each of those scenarios in bold, we work through potential outcomes that those scenarios may create, in particular as it relates to either a rapid decline of radiata or a gradual decline. And so what you can see across those four axes are some of the summaries that we feel may be present in that future state. And so in doing that, we identified how the industry may respond, or the areas that the industry may look to have an evidence base or resources at its disposal. So for example, if you look at the top left corner, what we're dealing with is an acute decline of radiata in response to predictable climate change. And so in that setting, we felt that the industry would experience increased fire, increased tree death, and as a result need to invest in genetic mitigation, potentially explore species options, ensure that there's a robust biosecurity response plan and a ready-to-go resource. However, on the right-hand side, where we're dealing with really unpredictable climate change and acute disruption to radiata, what you can see is much more intense flood, fire, cyclones, pests, and landslides, complete disruptive change, at which point the forestry model as it stands today would primarily need to be revisited, with the potential for shorter rotation, new species, an initiative to retrieve the resource that we may have today, and improve measuring and monitoring of climate risks to ensure that unpredictability was better managed. As a result of all those scenarios, the teams then looked at areas where investment may deliver value across multiple attributes, and then prioritise their views of where investment or action could occur. So what you can see here in the top left is that funding and investment, research and science, and information and data were all seen to be important areas, although of slightly different scale. I won't go into the details of those, but basically what we did was we took all of those summaries and we tried to take a framework that we could then identify where action may occur. And again, there's a lot of detail on the slide, so we won't be going into all of the specifics here, but essentially what we said was that there's a role for science to lead, and that's in the bottom part of the graph where we look at the innovation model. And at the top, there's an industry model where industry really needs to engage itself in this area in order to deliver action. And that could potentially be informed by research, but primarily it's going to be the responsibility of the industry itself to explore some of the areas that could prepare for disruption or develop a potentially alternative model to radiata. And so in doing that, we put the different elements on the left-hand side. So those reflect broadly the areas that were identified in the workshop. So things like funding and investment, policy settings, market opportunities, people and society. And down the bottom, some of the more specific areas where science needs to focus its energy. So particularly around things like people and capability, information and data. In terms of next steps, what we're looking to do is engage with our stakeholders to outline the framework. We've already shared the framework with the participants from the workshops, and we've looked for additional refinement and investment in that. In particular, we want to know how we could describe things better. We want to understand what we've missed, and we also want to then take it forward to work out what's already happening today. Once we've done that, we could outline what could be done and by who to materially progress from our current state to our desired state. And ultimately, this is activity that will then help to inform some of the decisions made by the FRC and subsequently, hopefully, the FGLT. So that's a brief overview. I appreciate I've covered a lot of ground and there's a reasonable amount of detail that I skipped over. However, hopefully that gives the attendees a sense for the approach that we're taking in these two important areas and where there may be opportunities for them to participate moving forward. Thanks very much, and I look forward to receiving people's questions.
Tēnā koutou katoa ko tainui waka, ngai tai te iwi, tōrere nui arua te marae, ko au ko Ramona. Good morning, my name is Ramona. I'm the portfolio lead for distinct value Indigenous wood products here at Scion. Good morning, everyone. As I introduced myself, I descend from the tribes of the Eastern Bay of Plenty, and my father's from the United Kingdom. My whānau own and manage 1,000 hectares of pine forest and 10 times that of virgin native bush. At Scion, I lead a portfolio entitled Distinct Value Indigenous Wood Products. This presentation is a summary of the tōtara industry pilot. I started out as a special advisor to the tōtara industry pilot, and in my capacity as portfolio lead, I am now supporting the pre-commercialisation phase of an industry. Ernest Morton was supposed to co-present with me. He lives in Moirewa in Northland. Unfortunately, due to lockdown, he couldn't be here to record alongside me. Ernest is the chair of Taitokoro Māori Forests Incorporated, which is a collective of over 20 Māori pine forest trusts that control 38,000 hectares of pine and at least that in native species. Ernest will join the discussion from his place in Northland during the Q&A session. So, why tōtara? In short, tōtara has been considered for many years a strong commercial indigenous wood resource. If you drive through Northland, you'll see tōtara on the hills, in the valleys and on the flats. It springs up in virgin soils, and when established on modified land, its preference is a sunny, dry aspect. Its umbrella-shaped canopy dominates the landscape in that region, yet only a few farmers have braved it as a resource. As a conifer, tōtara grows at a rate similar to rimu, kahikatea, according to Dr. David Bergen. That is around 26 centimetres in height per annum, 6 millimetres in diameter for the first 50 years. Tāne's Tree Trust and New Zealand Farm Foresters have been working on creating value from tōtara and other indigenous species for many years. With this species, an obvious pathway for value is timber. The softwood timber is naturally durable and it is beautiful. The tōtara industry pilot, or TIP for short, is a study into the viability of an industry in Northland that makes use of on-farm tōtara timber resource and permitting under sustainable forestry management. This industry is not just about timber production. It is about encouraging an appropriate and sustainable land use for all the many environmental, economic, social and cultural benefits that can come along with that. The scope of this project did not include plantation tōtara, the value of ecosystem services, or other streams such as high-value chemicals, although these opportunities were discussed during the study. The project was a collaboration between 5 project partners shown on the screen there. And pictured from left to right, Pita Tipene from Taitokoro Māori Forestry Incorporated, Elizabeth Dunningham, Scion, myself, Peter Berg from Tāne's Tree Trust, Mark Hollis from MPI, Paul Quinlan, Tāne's Tree Trust, Julian Elder from Scion, and Dr. David Wilson from Northland Inc. From here on, I'll refer to the tōtara industry pilot as TIP. TIP was the second stage in what has become a 3-step initiative. The first stage, known as the Tōtara Industry Project, took place over the course of 2014 and continued on into 2018. It could be best described as early tōtara industry and wood product work, where Scion, in collaboration with the Northland Tōtara Working Group, led by Paul Quinlan of Tāne's Tree Trust, carried out some early stage engagement with players in Northland to understand the interest in a tōtara industry. This wood was tested thermally modified tōtara, which produced some drying schedules across various cycles and sequences, and also tōtara durability testing. The partners in the study reflect these early stage discussions. As the study progressed, it was set up under a steering group and an operations team carried out the on-ground activities. In 2008, the relationship agreement was signed by the partners and the vision strongly Northland focused, he tōtara tūturu, he iwi tūtonu, sturdy tōtara, sustainable communities. This was drafted by the steering group to express 3 main ideals for the future. Firstly, that tōtara would be viewed as Māori once viewed it. Secondly, that tōtara would be actively managed as a commercial and ecological resource. And thirdly, that plantations of tōtara would be encouraged under the value of kaitiakitanga for future generations. This vision became the foundation for a successful study involving these partners with diverse interests and agendas. What you see on the screen before you is the kaupapa. Given the strong desire for Māori leadership expressed in the vision, Tai Tokerau Māori Forest Inc. played a big part in the development of steering group culture. Pita Tipene and Rawson Wright were members of the steering group. You can see here the fusion and harmony of the two worlds in the words, the old and the new, the contemporary and the traditional, the commercial and the environmental. Kei te tohunga te whakairo, literally translated, means from the specialist comes the thought. Figuratively though, its meaning expands to the carver brings the wood to life, the wood brings the carver to life. And in this juxtaposition or this dual view, the whakatauki becomes the strategic intent of the study and the future industry. Okay, here's the timeline. You can see here why we refer to TIP as the second stage in a three-stage initiative. Although it officially began in 2018, it included some preliminary work and a pre-pilot harvest carried out by Scion of 40 cubic metres of standing volume in 2017. A standing harvest volume of 95 cubic metres in 2018 and a final of 200 cubic metres in 2019. It also includes the handover to TMFI this year. This is the incredible team of specialists that were involved in the study. You can see Doug Gaunt and Jamie Agnew in the picture there. Okay, the study objectives. The main thrust of the study was at de-risking the opportunity for an industry to provide a platform. As stated previously, we had sufficient data before the study to conclude that a Northland industry was viable. What we didn't know was how viable and how all the pieces would come together to make it viable. In its entirety, TIP was 2 years from start to finish and cost $1 million. Under the leadership of Peter Berg as chair and Elizabeth Dunningham as project manager. Despite its complexity as a project, it delivered on time, on budget, and hit its milestones and the desired outputs. What you see on the screen here is a summary of the de-risked supply chain. During the study, we tested the supply chain. In essence, the tōtara industry that we worked on was A, naturally generating resource, B, processed by existing pine industry infrastructure that C, had some special challenges which required innovation. Permitting and harvesting are different in native species. Native species also require a different kind of handling and are sold into markets that aren't as sophisticated and as set up as pine. Prior to the study, there was also perceived to be a significant social licence challenge. The harvesting of trees took place on farmland under sustainable forest management permits. The permits took some time to come through from the council, and this was a learning for us. And this pushed the schedule out into winter, which is, as you can understand, not ideal. And the two harvests took place in May. The authorities were learning alongside us during this process. A point to note is that 40% of the permits in the Northland region for this period came from this study. As expressed in the strategic intent, having respect for Māori custom was a strong component, and tikanga was applied. This, in the picture to the left, is Ngāti Hine Kaumātua Edward Beattie offering karakia prior to the first harvest. Okay, timber processing during the processing and evaluation phase proved to be inefficient in the first harvest. It took some time to find a mill that was set up and had schedules that could accommodate the processing. So the logs were initially transported to Rotorua Toihohomai training mill. By the time the second harvest came around, a mill had been identified and the logs were processed at North Pine. We worked with 3 timber merchants during the study, BBS Timbers, JSC Timbers and Abodo. We arrived at a rough sawn value per cubic metre averaging at $3,200 per cubic metre. Some gaps were also identified. We had several opportunities to build the community into the study also. Numerous operators during the course of the project from Northland expressed a different emotion when working with native species. We also engaged in 10 stakeholder meetings to test the perspectives and opinions of Northlanders in a tōtara industry, from forest and bird to Tanes Tree Trust, New Zealand Farm Foresters, Māori and councils. Many expressed a desire to see tōtara growing. Some questioned whether adequate leadership from Māori was being given and a strong desire for this to be so in the future. Some wanted to wānanga on further aspects of this. During the project, several timber purchases and donations were given to the Handavasa Centre in Kawakawa, the church floor of the Samuel Marsden Church in Matauri Bay, and the laminated timber waka taniwha in the Auckland Park Hyatt Hotel in the Viaduct District in downtown Auckland. I would go so far as to say the study brought the community alive. Okay, so on the screen are the study findings. There were reports and collateral produced from the study which can be found on the website. I don't have time to go into the findings in any great detail. You can see here several pieces of output. One was a website, which you can see on the top left. Second was a newsletter. Third were several publications, and the fourth was the final report. We also had several news articles, one being a love story. Okay, post the TIP study. Since the study ended in September 2020, it was recognised in the Primary Industries Awards, incidentally the only forestry entrant and recognised project. At the end of the study, the TIP steering group also decided to hand over the IP and collateral from the study to the Māori partner, Tai Tokerau Māori Forests Inc. And the partners continue to support TMFI into the pre-commercialisation stage, where wānanga and further research will be conducted to conclude the findings. Business modelling, value chain optimisation, completing the final resource stocktake and a value chain strategy are also work to be concluded. TMFI is excited about the prospect of the next stage and how we can enable a Māori-led forestry industry. You can see here Ernest's statement refers to the benefits and the distributions that come through in several ways, both socially, culturally, environmentally and also economic. Nō reira, tēnā koutou, tēnā koutou, tēnā koutou katoa.